NASA says its Voyager 1, the most far-off human-made object in the universe, is sending usable data to Earth again. In the universe, we have no idea what it is except we can gauge it. Voyager 1, the notorious space test sent off by NASA more than 4.5 years ago, has recently conveyed back a message that has sent shockwaves through the academic community. Subsequent to traveling almost 14 billion miles from Earth, Voyager 1 has made a discovery so significant that it has modified the direction of its mission, turning around towards our planet. Join us on this grandiose journey. 7 minutes ago, Voyager 1 made an alarming discovery, turning around to Earth. But what exactly might this revelation be? Could it be proof of extraterrestrial life, a vast oddity, or something even more unfathomable? In this gripping investigation, we will uncover these stunning discoveries, as Voyager 1 just made a startling discovery that made it suddenly turn around towards Earth. If certain divine events hadn't harmonized, two of the most amazing rockets ever sent off may very well never have left Earth. In this case, it were the 4 biggest planets to align in our planetary system around 60 years ago. These planets were slowly aligning in a manner that had last happened during Thomas Jefferson's administration in the mid-19th century. This intriguing planetary arrangement went largely unnoticed at first. The first person to recognize its importance was Gary Flandreau, a doctoral student in flight at the California Institute of Technology back in 1965, when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was entrusted with sorting out the most efficient method for sending a space probe to Jupiter or even farther away to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made an interesting discovery. In the late 1970s and mid-1980s, all 4 planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, essentially reducing travel time. Flandreau determined that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary arrangement only happened once every 176 years. To exploit this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 spacecraft to make the journey, Voyager 1 and Voyager 2. These twin spacecraft were sent on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes on September 5, 1977, was something truly remarkable. At a place called Cape Canaveral in Florida, Voyager 1 embarked on its incredible journey into space, launched by a powerful rocket known as Titan III or Centaur. Only 15 days later, Voyager 2 was launched on August 20, 1977. Voyager 1 began its journey into the vast universe, following a shorter path. Their primary mission was to explore the gigantic gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these courageous space voyagers surpassed all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke several records on their inspiring odyssey. They ventured beyond anything made by humans before, even entering a region known as interstellar space, a completely unknown area within our galaxy. These exploratory spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles from us. Despite their enormous distance, they continue to astonish scientists with the amazing discoveries they make out there. Most recently, they have made a discovery so startling that it has taken everyone by surprise. The Voyager twin probes have accomplished several truly remarkable feats. Years ago, they studied the moons of Jupiter and Saturn, surprising scientists who initially believed them to be dull and pitted like our own moon. These moons turned out to be lively hubs of activity. Voyager 1 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it zoomed past Neptune, an accomplishment unequaled by any other spacecraft. As these spacecraft continue their complex journey, NASA used some clever strategies to ensure they stay functional. They've deactivated unnecessary parts, like extra components and heaters, to conserve power. The plan is to keep the spacecraft operating until at least 2025. For the dedicated scientists and engineers who have been part of this extraordinary journey from its inception, it is a mix of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a shocking discovery emerged from the depths of space. At the start of their incredible journey 40 years ago, the Voyager spacecraft amazed experts by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pitted like our own moon, turned out to be dynamic worlds. Voyager 1 reached Jupiter in March 1979, only 546 days after its launch. Voyager 2, following a slightly different path, arrived in July of that same year. Both spacecraft were equipped with special cameras that used filters to capture full-color images. Interestingly, they were designed to be very steady, rotating through space at a rate more than 40 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 photos of Jupiter and its moons, each revealing new and fascinating details. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked, icy surface estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a speed boost of 35,700 miles per hour from a gravitational slingshot, a critical maneuver that propelled them toward interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's magnificent rings and endured thousands of impacts from tiny dust particles before flying by Titan, a moon surrounded by an orange haze, and traveling north out of the plane of the planet's rings. Voyager 2 continued its individual journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Only 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, killing all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Voyager 2 flew over Neptune's stunning sky-blue methane atmosphere, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar neighborhood, with surface temperatures plunging to a staggering -235 degrees Fahrenheit. The moon's frozen volcanoes were another remarkable discovery, shooting nitrogen gas and fine particles up to 5 miles into its atmosphere. After Voyager 2's captivating images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the mission's official end, NASA extended the mission with hopes that the Voyagers would venture into interstellar space. In August 2012, Voyager 1 achieved a stunning milestone by venturing beyond the heliosphere, a vast region of charged particles created by the Sun. This surprising achievement became widely known the following year when a study was published in the journal Science, sharing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a strong solar flare between April 9 and May 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found inside the heliosphere. At first glance, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explain that the electron density at the edge of the heliosphere is significantly lower than on Earth's surface. By analyzing Voyager 1's data, scientists pinpointed the spacecraft's exact flight date as August 25, 2012. This determination was not based solely on electron movements but also on measurements of charged solar particles collected by the spacecraft on that important day. For the Voyager team, this announcement was a source of immense pride and satisfaction. Susan Dodd, the project director, expressed the team's excitement, saying, "We are thrilled to have been able to keep working with the explorers and to see it achieve the incredible milestone of entering interstellar space." Ed Stone, a key figure in the Explorer missions from the very beginning, emphasized the significance of this achievement in advancing our understanding of space. He said, "Voyager has led us to new discoveries by giving us the first view of this new region, expanding our scientific understanding of the nature of energy and radiation in space." Voyager 2 also crossed into interstellar space in November 2018, venturing into an unknown area beyond the Sun's protective bubble, which shields us from cosmic radiation. However, the truly astonishing news comes from Voyager 1. After an incredible 46 years, NASA's Voyager 1 spacecraft, the most far-off human-made object in space, continues to send valuable data back to Earth. Despite its unprecedented distance of over 14.7 billion miles, the spacecraft remains functional, although its primary mission has long since concluded. However, here's where things get really exciting. Voyager 1 has recently made an extraordinary discovery that has left scientists both baffled and deeply concerned. As Voyager 1 traveled through space, something unusual occurred. It began sending data back to NASA, revealing an anomaly in its trajectory. The data indicated signals containing information about an unknown phenomenon that defied explanation. This anomaly seemed to suggest a massive, previously undetected object exerting a tremendous gravitational pull, distorting the spacecraft's path. This discovery has shaken the scientific community to its core, sparking a whirlwind of speculation. Could it be a rogue planet, a black hole, or something entirely phenomenal? The implications are staggering. If confirmed, this newly discovered object could challenge our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, using all available resources to analyze the data and potentially divert Voyager 1 to gather more information. This startling twist in Voyager 1's journey serves as a reminder of the vast mysteries that lie beyond our planet and the enduring spirit of exploration that drives humanity to seek answers in the far reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had an expected operational lifespan of 4 to 12 years. Remarkably, Voyager 1 has far exceeded expectations, continuing its mission for an incredible 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce power through the heat generated by the radioactive decay of plutonium-238. Despite this remarkable perseverance, NASA estimates that by 2025, the Voyager spacecraft may no longer be able to generate enough power to operate its instruments and transmit data back to Earth. During routine communication with Voyager 1 via NASA's Deep Space Network, something extraordinary occurred. After more than 40 years of continuous data transmission, NASA's computers on Earth began receiving an unusual signal that left everyone concerned. For the first time in its mission, Voyager 1 suddenly halted its journey and performed a complete 180 degrees turn. This unprecedented 180 degrees turn by Voyager 1 has left experts baffled. It is unlike anything the mission team expected, as the spacecraft had been on a steady course, traveling ever deeper into the void. What could have caused this sudden, unanticipated reversal? Initial analysis suggests the possibility of an unknown gravitational force influencing the spacecraft, something that no current models predicted. NASA scientists have scrambled to understand what this could mean for the mission, and for the future of space exploration as a whole. Voyager 1 had been sending back a series of peculiar signals for several months before its unexpected maneuver. These signals, unlike anything previously detected, displayed an unusual pattern that suggested a disturbance in the spacecraft's path. In particular, the spacecraft began to drift off its intended course, eventually performing a sharp turn toward Earth. This anomaly is unlike anything recorded in the history of space travel, sparking both excitement and alarm among astronomers. Could it be a massive, previously undetected celestial body? Some scientists are speculating that Voyager 1 has encountered an invisible or nearly invisible object that's exerting a gravitational pull strong enough to alter its trajectory. There is a possibility that this discovery could be the first evidence of a new class of objects in space, objects that do not fit the conventional definitions of planets, asteroids, or stars. As the mystery unfolds, theories abound. Some experts believe that Voyager 1 could be the first spacecraft to come into contact with a dark matter structure. Dark matter, an elusive and invisible substance that makes up much of the universe's mass, remains one of the greatest mysteries in astrophysics. Could this anomaly indicate a dark matter concentration? Or might Voyager 1 be encountering a distant, previously unknown form of celestial energy that we have not yet observed? Even more startling is the possibility that the spacecraft may have stumbled upon a form of cosmic energy that could have implications for both space travel and our understanding of the universe's laws. The turnaround, coupled with the mysterious signals, could indicate the presence of an advanced or unknown form of technology in deep space, perhaps from a civilization far beyond our comprehension. If this theory were proven true, the ramifications would be staggering.